So this is question 2 for the homework 11. Question 2 is it is suggested that the following function of v and v is equal to a is sub question A is fv equal to distribute function v is equal to fv equal to e to power negative absolute value v. B is fv is equal to sine square v over v square. So C is fv equal to 1, or for absolute value v is less than a, equal to 0 for absolute value is greater than a. May represent an autocorrelation function of wide sense stationary stochastic process by setting v equal to tau, or a spectral density function by setting v equal to omega, or both, which functions fv may represent as or both. Explain your answer. So if autocorrelation of tau is an autocorrelation function of a real wide sense stationary stochastic process xt, then it is even, and tau is less or equal to r0, and its Fourier transform is non-negative. If the spectral density function omega is a power spectrum of a wide sense stationary process xt, then it is a non-negative. So for the question A, so it may represent an autocorrelation function because e to power negative absolute value v is even, and it fits this rule. There are tau, the autocorrelation tau is less or equal to autocorrelation 0, and the Fourier is non-negative. It's non-negative. It's for the Fourier function transform is non-negative. So for the power spectrum, it's also represent a power spectrum, since it's already said here. It's a spectrum of the SW spectrum is a power spectrum of a wide sense stationary process, then it's greater or equal to 0. For the B, so it may represent an autocorrelation function because this part is even, and for the limitation tau approach to 0, and the whole thing is less than the tau approach to 0, which is 1. And here it's non-negative. For the graph shows it's non-negative. And it may represent power spectrum also because for this part is greater than 0, greater or equal to 0. For the last one, it can represent an autocorrelation function because its Fourier transform is 2 sine alpha w over w, which is not non-negative. It cannot, since this part is not non-negative. So it may represent a power spectrum also because fw is greater than or equal to 0.